this is Meetup, and I was trying to understand how many guys are developer and architect and working around AI. So can you guys show up your hand? How many we have developers, architects, and AI? Very less, I think. Then I did good thing. I added one more slide. Audience. So, yeah, little bit about me. So, myself, Rakesh Kumar. I have 18 years of experience working in various companies. And just a disclaimer, this is my own opinion or views. So, it's not related to my company and all that. Go next, right? Yeah. So, because of we are having a lot of guys who are working in the software industry and they are software developers, and then I thought that how I can make them understand what is AI and all those stuff. So this was the slide I was referring quite long back, and it's given me good understanding. So far, whenever we develop software, like what we do. So we usually do coding, which is effects here, and then we also give the data, right? And what it does, those logics goes and runs on the CPUs, and then it spit out desired behavior, whatever product team has asked for it. Then, just to understand what is this AI and steps are shaping up, right? So what happened over a period of time, still that software development is going on and a lot of engineers working around it. But seeing the volume of data, variety of data, versatility of data and other concerns, adoption of internet, mobiles and all those, we started pumping a lot of data. And then our traditional approach of building a logic, running on CPUs and extracting some stuff becomes hard. So we all went through big data scenarios. We were having a lot of technology around it, Hadoop, big data, other software like Spark, and then there were a lot of evolution around it also, multiple storage structures, right? So we started working on somewhat, we were able to deal with that amount of data. But over a period of time, what happened, those were still somewhat structured data. We started pumping a lot of unstructured data, images, videos, audios. Then parallelly, data science was another study, discipline of study. It was not technology, known as a technology way of studying. But we were having AI since long over there, and another set of research was going on, and it was kind of research oriented job. So what happened then? There were some twist around it. So those data scientists and all those what those guys were doing, they were extracting the patterns of from the data. So they were based on the historical data, set of different data, they were extracting patterns, and based on the patterns, they were building some logic, right? And that's where I'm trying to depict here. So data and desired behavior. So we already have X data, and we already knowing that okay, if this was the temperature, this was the our geolocations, this was our historical date. So I'm able to say that okay, there is about to rain. That kind of prediction we were able to extract from those data. So what happened, based on those data and output, we all given those historical data and desired output to machine, and machine generated formula. That's nothing but FX code itself, and it built the cognition of understanding of those data, and it's become a formula, and then that's become a model. Just try to visualize that become model, and now that model has to do the real work. So whenever unknown data will come, it has to predict what will be the next action. So to run that model again, we need another set of compute, probably traditional model we were able to run in CPUs, but now we are considering for GenAI scenarios. So we required GPUs. So for inferencing, that is called by the way inferencing here. And when we were building that, letting machine know the patterns, that was called machine learning, training or machine learning period. So for inferencing, we started hosting them in the GPUs, and then it's got unknown data, and then it started giving the unknown behavior, what would be the output. So I hope I made the context, what is AI and all those, right? I explained it a lot, and we started calling software 2.0. Right. So again, background about AI. So we had AI, artificial intelligence. Then within that we have machine learning, and machine learning was just traditional machine learning models we were building based on the historical data patterns and all that. After that, deep learning areas emerged. So deep learning is nothing but it's a kind of so what happens? We had a lot of data, but still whatever pattern recognition mechanism was mostly mathematical and statistical pattern was there. So it also started saturating. So over a period of time, scientists started thinking, why not we can build a solution the way the human thinks. So from there, okay, we'll wait for that. So it comes.
It will come in 10 seconds. You can continue.
So from there, what happened? Scientists started thinking that why not we can build some other way of sensing or looking around those data the way humans sees. So how humans sees over a period of time, whatever we have observed, we have made our intelligence and knowledge base, right? Even by explicitly or implicitly whatever we have seen or taught, that's become our knowledge base. So with the same, and how this knowledge base works, because we have biological neurons in our brain, right? So that's how we, all senses works and capture inputs and make some understanding out of it. So we are here, everyone is looking around, but each one will be making their own different sense about this knowledge. So same way, this deep learning was kind of era where we started building artificial neurons. So that was the concept around deep learning. And within deep learning, the subset of another learning is generative AI. Right? So just to make a mind map, if you would like to build your thought how it is. So generative AI is part of deep learning itself. And so in generative AI, what happens? So far, we were predicting and up to that point, whatever model we built, what that model was doing, that building up kind of understanding and some logic, and based on that it was predicting what would be the next outcome. So it was not a purely new things, but now what happens when we get into GenAI, we started generating new content which was pretty much new to the world. It was not duplicated, and that's where this GenAI era started. There were a lot of things, but I am abstracting a lot. So what we started calling it out generative AI, and what it does, it generates images, text, audio, video, and code, and whatnot. And within generative AI, which is my topic, which I'm going to talk about, which is agentic AI. So now everywhere every company is building their own agent for all the tasks. So agentic AI is nothing but a part of generative AI, but here what is agent will go into detail. Okay, so for generative AI, traditional models we were calling when we were having traditional machine learning. When we came into Gen AI, whatever model we were having, we started referring as a LLM, large language model. I think most of the folks know about that, but I will try to make some sense. So when we started building LLMs also, that there were multiple phases. So in phase 1, it was simple model, basic input output and some rule based or some prediction based. So at that time we were building rule based chatbot, simple neural networks. So that was the era, that was the initial era. And then what happened, it was so we can relate those era with the Google search, right? So before this GenAI got popular, GPT and all that, we were having this those capabilities. In Google, autocorrect was there, right? We were searching in Google, it was able to predict the next word. So that is the era of phase 1, we can refer back. So we were having those kind of capability, but it was just for giving you one or two words. But what happened, we started expecting a lot of giving input to that model, not only one sentences. Probably I can say one paragraph and then it should be able to predict the next actions of the drama or whatever. So with that, that was the requirement, and then we got a paper from Google that attention does what all we need or something. That was a very popular paper, and that paper changed this whole neural Gen AI neural network way of building models, very different way, and that's where this transformer came into picture. So from that paper, transformer architecture was span up, and then people adopted that transformer architecture, and they started building various models. So few of the model was GPT series, we all know, and Google also has Bard and all those. So that was the phase 2 era, right? And then in phase 2 era, we were able to build model, and chatbot kind of scenarios was there. Okay, I'm asking some question based on the all the internet data it has, those models behind the scene, and it was able to answer my question. But we didn't stop there. We started thinking, okay, that those LLM has all internet data of knowledge and it is able to answer. But what about if I'm an enterprise, I would like to build a system where my employee can ask, hey, what is my HR policy? That model can tell that. So that's where grounding those LLMs to the proprietary data or very SMT data. Then we started another architecture, we called it RAG, and in that we started building RAG-based systems. So with that, all these GenAI-based applications were able to contextualize in the local database. So let's understand how does LLM understand any language. So LLMs, we all know basically, right? It's a somewhat a model which has understanding of all the internet data, lot of books and all that. So how does it understand a language? Whenever we ask anything, right? So what it does, first of all, our input sentence get encoded into some binary number. So it has some encoding. There are a lot of encoding techniques in AI/ML if you learn, but it does internally because we are using ChatGPT, right? So model, GPT are all the way of interacting with LLMs, frameworks being provided in the market. Those guys has all this encoding capability. So this text goes to the model, and then based on that cosine similarity or a lot of other stuffs are, we will discuss about that. So based on that, it goes and figure it out what are the similar text are, and it's bring in and it's give us the output. So that's how it's generated at high level. Right. So yeah, how does it generate? So because it has a big data, we all know, and a big compute wherever it is running, and it has trained model on all those data. So that's how it is able to. By the way, so far, if anyone has any question,
those tokens are internally binary only, right? The conversion.
Right. So those tokens are binaries, but there is some relation between that. So in the market, there are a lot of model LLMs, right? So it's not like you can have any encoder and give the input and it will be able to understand it. So each model provider, they are having their respective encoder as well. So, yep.
This is for not for purpose of security, right? It is more of like how they are going to run the model and get the feed from the data and get out. Like, internally, are they matching or what?
Right. So I have abstracted a lot here. Means how they are matching. There is a quotient similarity, one of the mechanism formula. There is a after encode. So this is the when we are querying it. But before that, how it has been trained, we have to understand that as well. So for training also, just understand the first line of text has been given to model. It's not only this one. They are trained with all over internet of data, all the Wikipedias and all the lot of good books. So you can understand how much data it has. So during training, there is a good piece, I think, I need to call it out, that is vector data. So inside it, so what it does, when all the texts are getting encoded, in vector database is the technology where it stores all these numbers in multi-dimensional space. So it is magic altogether, but you can understand all these texts has some context. How this model able to understand the context? If I'm saying one sentence, how it is able to understand? Okay, I need apple. I need an apple fruit or apple mobile, right? So it has a database and multi-dimensional space. So these numbers goes and stores, and whatever words try to understand, each word has been encoded to some number form. So that technology is that much efficient. When it stores, it understands that okay, I have an apple, so it will keep that apple in a near to fruit also, and in electronics area also. Okay, and based on your full sentence, based on your previous conversation with that model, it will try to understand that are you referring the apple fruit or apple mobile. So it has, there are a lot of algorithm into it. It goes through a lot of, if you are going over all transformer architecture or some data science course, you should be able to understand. But behind the scene, that's how it's figured it out. Means that black box itself will figure it out, okay, what you are referring from your whole sentence.
So that is back-to-DB as or on top of that there is a transformer who does that?
And that's a transformer architecture. So model LLMs are built based on the transformer architecture. So that's a transformer architecture behind the scene. But for encoding, when we are communicating with model, again that model is not able to understand your language, right? So that's why we need this encoding to be done, and also this encoding algorithm should be compatible with that model. Based on that, whatever it has encoded and maintain all those database, so that it will be able to throw the query to the database and able to fetch the response.
So this format is uniform for all the models, or it's like
No, this process is uniform,
but
but encoding which model or which algorithm you are using, it depends.
So the token value itself refers to the location on the vector graph, or it's a map?
You are asking very hard question with me. So first of all, you have to understand how anything getting stored in multi-dimensional space.
So in multi-dimensional space, it has, depending on how many
Correct,
dimensions you have, it will have that.
Correct.
So token is a map to that specific location. It doesn't itself show the location on the graph, right? I'm assuming there is a mapper somewhere where you will transform the token actually to the vector graph location point.
No. So if that is a vector graph based database, for me, the only thing is it has all data. For example, in a simple any SQL database, if you have some kind of masking or encoding applied, right? So if you have stored your encoded database text into it, you should be again asking with the same encoded logic, so that it should be able to give you a response, right? So that's where. But behind the scene, there are a lot of things. I'm understanding a lot. If you are very interested, you will be spending time.
Token is a kind of the encoding decoding algorithm, right?
No. So there are a lot of encoding logic also. Word to vec or there are multiple. So just try to understand one word has been given one number. For example, we are having lot of words, right?
Just any
Unique number. So there are algorithms which will be encoding these words and giving you a unique number, right? And that unique number will have a, when it goes to multi-dimensional space storage system, it will have a lot of context associated with that.
So for the word apple, the token value is the same regardless of the context, or does it change depending on the context?
That's changed.
So apple in electronics context is a different token value,
Correct.
and in fruit context, it's a different
That's,
token value.
that's again how we have, means for a smaller use case, right? For a smaller use case, if I am building a small database, then what I will choose the logic, okay, each word I will give somewhat unique word, unique token, right? Now, if Apple has 261 value, it will have a 261 only. Now I am saying that okay, there is I need apple, I eat apple, right? So what will have eat word and need word has to have a means how much closer in multi-space it is being stored. So that's how if it is been eat has been very closer, need has been somewhat distance. So what it does, it will I apple if you have typed it. So what it will say, okay, need is missing. It seems like it is asking for need. So that's how at conceptual level try to understand. I'm not a data science guy to make it you guys understand. Yeah.
One last one. Sorry. The generation of this, I would say the numbers that we have, it's on the algorithm level, right? once we enter the chip from chat to statements. So underlying thing first it is doing this token generation and then thereafter they are processing again. Because this, in my opinion, this token generation is happening based on the context as you said, like what context we need. So there should be one layer or some logic where they are determining okay what context user is asking about. Because if you enter multiple times multiple sentences, then the second one that you are entering, it always goes and check with the previous one.
Correct. So that is called context, right? You bring a very good point. I will touch upon that. That's where so nowadays model is also coming up a lot of capability, reasoning, and all those. We will touch upon, but I will show you if within our application, if we would like to maintain context, how we will maintaining or how we will be passing context to LLM. Because in conversation scenario, obviously context is must. Because when you are searching in Google, just you are searching anything. I need apple or something. So it doesn't mean it's fixed. Always it will give apple. If someone has searched something earlier, it will give something different for him. So it's not a LLM, it's predicting, because that search engine you have already logged in. It has your previous context, and while querying to the LLM, it's giving as an input. That's where it is able to give different answer to you and different answer for him. So how we build application, I will touch upon, then it will be more clearer.
Before you move, just one
Yeah.
we are calling it as a token. I mean, if like to me layman language, I understand token in a different way. Here I don't think or I can't relate why we are calling it token as a token. I know it may be
Right. No,
something that they've decided.
that's a good point.
Transformer
It's
architecture.
kind of key, right? It's kind of the
Correct. So LLM is a black box, right? It has a knowledge. So what it has, and even though we understand vector database somewhat and understand how it goes and sit into that database in multi-dimensional space. So it's not that word goes and sit over there directly. For me also it's hard to explain that, but I'm trying to make it understandable. For example, this is English word, right? I'm saying man, but in another language it should be some other things, right? In Hindi it could be different in different languages. But the sense is same, right? Sense is same. So that's the problem this LLMs or storage system behind the scene solves it. So what it does, it understands that sense, and that's where these encoders or intelligence, they have those knowledge base. If you are giving in English, man, it will understand, and it probably, I haven't tested, but it will give the same token number to man in English and man in another language. Okay, so in that case, the token value is same, unique, and it will go and get stored. So that's why with LLMs, when we are asking in any language, it is able to maintain that context and able to respond us. Right? So there are a lot of study you have to do, I have to do also.
And just to add on to you, Rakesh, like whatever you said, in simple words, whatever I have understood so far, token is basically the equivalent hashing of your string.
Correct.
So
just try to understand that things. Okay.
Given any input string,
Ah.
it will always result in the same vector token number,
Correct.
right? But if the language changes, the token number also will change.
Right.
And-
Might be.
You said it doesn't.
No.
Same.
I will not comment on that. There are a lot of techniques.
Yes, techniques.
Yeah,
We
okay.
should continue.
Okay. So that based on those techniques depends.
And token is
Just to
not-
simplify, I think this is the best way. Just understand that it is has value of all those.
So given any input string, if you take a MD5 hashing in simple words,
Same.
MD5 string will always return with the same string.
Correct.
Same, right? But from MD5, you can never take back the data back. input source. That is impossible. I mean, that's the reason it is 128-bit encoding, right? So, but here in this case, for any string, it gives you the vector representation, and this is how the LLM provider actually charge you. So the whole LLM business model, right, typically runs on the length of this. The more length you have, the more bill you will get if you are paying it yourself. Okay.
So I think everyone is beginner, so that's where I'm trying to make it simple. Just try to understand, but there is a lot of things. Once you go inside encoder also, there are a lot of techniques, a lot of model why this one is better, this one is not better. Yes, sir.
A word does not mean a token.
Right.
Let's have clarity that every word does not ChatGPT or anything. It does not translate to one token.
Correct.
A word can itself
It's
have multiple tokens.
similar to that.
Similar. So let's not confuse it.
Correct.
That's
So-
and tokens are not permanent.
Right.
It changes.
Correct.
If what you put as an input, let's say you put a sentence and you just change it separately, the tokens will be different. And you can check this out. There are tools, ChatGPT. There is you just search OpenAI ChatGPT tokenizer. You put a sentence.
Right.
If two people put
I have some
sentence,
demo also. I will somewhat show over there. But there are a lot of things.
it is.
He is right.
It's a fixed thing. You change it like because of the similarity, as he said. They just track out the context what is there. They figure out where the token and which data should come next. Token is not
Correct. Yeah. All right. Let's move fast. So, okay, we built the LLMs. We know I have to throw some strings. It will get encoded and it will go inside it and it will give some output. So that was amazing. It was generating new things, right? But then how we should be leveraging those LLMs in our all development and all that. Then prompt engineering one comes came in. So now we have to learn how to interact with LLMs, right? So that's where a lot of evolution happened. And then after that we touch upon RAGs. So if I would like to ground those LLMs to understand my data, then I have to follow that RAG architecture and build those applications. Then fine-tuning and pre-training. So fine-tuning, again, it's very heavy, costly and complex problems, and pre-training means you are going to build from the ground. So again, you have to take all the Internet of data, building and all that. So this is the current industry trends where mostly we are dealing with prompt engineering and RAG and agents kind of development happening. Okay, so in prompting itself, we had one way of prompting. This is called prompting 01. It's nothing but I'm asking something to LLM, it's giving response. But that was the direct interacting with LLM. But I would like to build some application, right? So then this typical LLM app prompting, what happened? There is a prompt template terms, which nothing but it gives you a structure. So in that, if you can give the system message, some example logic how you have to think. If you are asking LLMs to solve this problem, some reasoning, logic. So just give that logic, write it out. To solve this kind of problem, you will be thinking in this way. And some example, if you give example to solve any math problem. So and with that user input, it will get attached and it will go and send to that LLM. Then it will be able to give you the right answer and able to solve the problem. Then again, what happened? Okay, one prompt template was fine, but we started building a workflow with kind of scenarios. So we started with prompt templates and whatever response was, it goes into another model with that different. I think I haven't changed. The prompt template should be 2 and 3. So this is how different prompt template and earliest model response will get embedded, and then it will become input for another model, and similarly after 1 or 2, the way workflow you have designed, you will get final response. Right. Just to understand RAG architecture, what is it? I think I found this one is pretty good to understand. So in RAG, it is 2 parts. One is very first, for example, for LLMs, they know a lot, right? For example, any college graduates, they know all the engineering things. But what we do, we train them on a particular company setup. Now you know everything, but you have to work in account department. So you have to know this particular domain knowledge. So with that analogy, if I would like to ground those LLMs to my private knowledge base, what I have to do, I have to input those data. So we build the input pipelines, we are productionizing, but in the short form, we are having data, and those data, what we have to do, we have to divide in chunks, and then embedding has to done. The embedding, nothing but the way encoding I was showing. So that encoding has to get done, and then it will go and get persist in a database we call vector database, right? And then this consumption side will start. So now that the student has been trained in account department, now some manager will come and ask, hey, give me this customer's whatever status is. So it would be able to give all financial records, and he or she should be aware of now. So this user thing, again, user query will get embedded in coding, right, the way I was saying. And then a semantic search has to apply in the database and take those, what are the related stuffs are with this query, give me, and that will become a input for LLMs. So in prompt template I was telling here, right, the context I am giving, system messages, example logic and all that. So with the same things, whatever related with that query it finds in my local database, it will attach in that template, prompt template, and it will bring to that LLM. And now instead of LLM reason on its own data, it has to reason on whatever data I have given as a context. And now it will answer to the user. So at high level, this is the RAG architecture.
So what's the rank results here? So what are the results?
Right. So here
So the custom implementation you will have to do beyond the database and everything.
this has been, there are a lot of things, but for now just forget about that. Because what will happen, there will be, if you are searching semantic search, right? So you will get a kind of 20 result sets. So again, which one is more relevant? Because you will not give all 20 to LLMs, right? So then you will have some ranking and filtering criteria, so that you will take only few, and you will give LLMs to just think around this and give the answer based on that. So those are the
Yeah, I mean that's how you will have to implement on your own to feed the LLM.
But now don't need to do that. I will have a sample for sample application. There are a lot of intelligence things has been came up in the market. So
Doesn't LLM itself implement the semantic search?
right.
So
So
semantic search different from?
semantic search, because this is my corporate proprietary data. I can't give it to the LLMs, right? So what I'm doing, I'm maintaining in a database that I'm calling vector database. And that vector database is not a syntax search database. It's a kind of semantic search getting applied, right? So that's where to search on the database. I'm giving that query, and it is searching based on the semantic logic, and that's where we call it semantic search.
Can you give an example of a semantic
It's
search algorithm?
So for example, cosine similarity itself is a kind of semantic search implementation. So semantic search in the sense, in database we search, we say that okay, so far now we have indexed all the data, and I'm saying that okay, imply Rakesh, right? So what it does, it goes and searches wherever Rakesh is in the first name, and it will fetch all those results. That is nothing but it's a text-based search, right? Exact match or like keywords we apply and we get that. But when we are telling semantic search, that means it's going and it's searching based on the meaning of that data, meaning of that word, instead of going and matching its exact words.
Can I give
So,
a bit more explanation?
Yeah, please.
So, we are talking about a vector database here, right? Typically, what happens is when you are doing an embeddings, it could be an image, PDF, whatever it is creating a vector form of it, mathematical vectors, right? Okay. So, it's like a three-dimensional coordinated vector system you are representing. When user fires a query that, it could be images also, it need not to be a text as well. When a user asking that, as simple as that, take an example, you have an internal data support manual, right, basically. How do you respond to your user queries? Right, it has all like, I bought a subscription, it's not working, app is not working. So you'll have a troubleshooting document. You put all that embedded data into vector database. When user, when support person, let's say queries, this is the issue user is facing. That phrase, it will convert it into a vector again, right? It will try search in the vector database, what are the closest vectors to this? In a mathematical format, right? What are closest vectors to this search, what is coming in? It will give the relevant documents that are closest to that vector. And whatever is the documents that are coming in, you are passing it to LLM. Yeah, it will make it more humanized.
Yeah, alright. I think we will cut down. I have very limited time. I have to demo as well. Only 5 minutes. We will discuss offline. Let me run through quickly. So, yeah, that was the RAG. Then what happened? Multi-dimensional AI models came in. When multi-dimensional means earlier it was text to text. Now I will ask in text, it will give me audio, give me images and all those. So that was the evolution. And then reasoning AI model started coming in. So reasoning in the sense observing the inputs and internally itself it will try to reason about that. For example, if you are saying that hey, you have to book the flight ticket, so it will be able to understand if I have to book the flight ticket, I have to search for it also, right? So it has those reasoning things into it, and then agent things came in. Okay, so for agents, let's try to understand. So this agent guy will be having, it will have this construct. So what it will have, it will have a goal. Means you have to give, so agents are nothing but it's extension of those LLMs, application development, where we are thinking to build a subsystem which will be autonomous in the sense of performing any action. So if I am given the access to all my payment system and all that, so if I am saying that hey, book a flight from here to Delhi to Mumbai on this date, so it has to be able to operate everything. So that's the thought around agent. So agent will have a goal and it will be able to do planning. It will be able to understand, maintain the memory, previous memory as well. If I have made a conversation, it will have a tool access. Means it will have some external tools, web search, my bank accounts, connectivity and all that. Actions, it has to perform some actions, and it should be also able to interconnect with another asset. And then environments level, environment-wise understanding, it should be able to have. So in a typical agent way of interacting is, I will be able to give a simple prompt. So what it has to do, it has to follow the prompt template, it has to connect with LLMs and whatever conversation. So in connection with LLMs and tools, based on their reasoning itself, it will be able to understand what I have to do. I have to connect with flight booking or Google. I have to first search on the Google, get all those flight details, then I have to go to particular flight booking site and I have to book, right? So all those reasoning capability will be within events and it should be able to do that. So in a simple way,
One question.
okay, I'm going very fast there.
Let's go back.
Yes.
So what people really think it's a DB or it's a in-memory things or
Okay, so these memories are in memory for agent. Okay, so in that software term, in this one also they are having a short-term memory, long-term memory. So if you would like to build a system and which has a lot of conversations, so you should be having long-term memory strategy also. So you should be providing your secondary storage connection so that it will automatically go and on. So this is the concept. Technology wise, there are a lot of way of implementation. Right. So I will run a bit fast because I should show the demo as well. So yeah, so agent will have its own runtime and within itself, right, we are talking about how it will reason and all those. So it will have all these orchestrator. I'm showing these things because I would like to come to this point. Because to build those things, right, all those things are good, but when we are building any application, it's not that easy. So if we have LLM, then we understand that, okay, if I would like to conversate with that LLM, I have to import with their compatible encoder and I have to throw those syntaxes, then it will be. So building a system, it's not that easy, it's challenging. So, also it's costly and if there are LLMs, they are having their API exposed, if you are building all those memory management tools and all those, you have to work a lot. So I will make it short. So the solution is we need a framework and tool to develop all this. So in market we are having a couple of frameworks. This is very popular is LangChain, right? And LangGraph, Llama Index, QAI, Autodesk from Microsoft, they are open source. Amazon Bedrock is there, PyData is there, and LangFlow. So few are open source, few are paid. So LangChain, LangGraph, I think LangGraph few components are free. Llama Index, Autodesk is Microsoft's open source. Amazon Bedrock is the paid one. PyData, again this is open source, right? And few are a kind of low code, no code kind of things also. So nowadays in the market you don't need to code, just you do drag and drop also, you will be able to build agents. So those kind of capabilities are so far. Software developer, there are a lot of life easy. If you would like to onboard, just you have to learn and get right on GenAI and AI. So yeah, so LangChain, just to try to understand. So for LangChain, this is a kind of system. It provides the inbuilt capability. So if you are given some instructions as action, so what it will do, it will observe, have an observation capability. So these are provided by framework itself. So now you don't need to think as well. Just you need to understand how this frameworks works. Then it will do thought and final answer it will give. So this is the framework capability. So for example, I have given a question, right? And this is the original question. And what happened? I'm having this agent. So agent will have a tool access. So for one question, it will go and it will ask agent to answer that. Then what it will do, it will interact with external tools, get the answer, and again it will go to get into another prompt, and that again it will become, for example, booking a flight itself. First it has to go to do the Google search. So there are search engines, DuckDuckGo and all those. So you have to point it as a tool. So it will go and make a call, then you will be having flight book answer.
So the answer is here like the output, but the finally it will like
Finally,
book the ticket.
yeah, book the ticket, or it's required input from the
Yes.
user also, it has to
So
prompt.
they might ask prompt.
Right, yeah.
So it's a kind of Jarvis.
Huh?
Jarvis.
Jarvis?
It's okay. Whoever is Marvel fan, they can understand.
Oh, okay, right. Yeah.
But by
Yeah. So then that was the agentic way of building things, right? And then we came into era where we started talking about multi-agent system and architecture. So just understand it's nothing but more than one agents are solving whole problems and all that. So for multi-agent architecture, these are the architectures primarily getting used. So single agent, so as of now, whatever we discuss, one agent having access to two, that is the example. Network of agents you can build, and they will be communicating with each other. Supervisor, always each agent has to respond back to supervisor, stuff to other, and what's not. So the way we are structuring our workflow, this falls under one of these architecture. Let me quickly go over a demo and show you with LangChain. I think I am having very limited time, but is it visible? So this is nothing but search engine with tools and agent. So far I was talking about. So I'm using LangChain. So I have to import LangChain community, right? So this is LangChain and this is the tools component. And I'm saying that from here, just import this archive. Archive is nothing but all patent related data they maintain. This is the Wikipedia if I would like to set to Wikipedia. And this is another utilities if I would like to have some wrappers, and there are a lot of stuffs, right? So these things required. And yeah, so this is nothing but a standard code. I would like, I'm having my OpenAI and Grok API keys in environment variable, so I'm loading it here. And then what I'm saying that, okay, Wikipedia wrapper, I'm instantiating, I'm telling it, okay, whenever you will search, you have to bring only one result, right? And the current document max characters, it should be this much. Okay, so and I'm instantiating this Wikipedia. So there are construct, right? Queryable, runnable. There are, if you learn LangChain and all that, so there will be new terms. So runnable is one of the construct which lets you invoke. So we were having iterator in our .NET and all that, right? So these are the wrapper which lets it invoke at runtime. So just try to understand that. So I have built this, I given this name, right, and this is RC, and similarly I have instantiated RC as well. Now I am building this tool. So I am saying that here, this is the tools, you have wiki and you have having RC. These are the tools. So one agent I am giving tools, right? That's how it will work. Without tool, what it will do. So now what I'm going to do, I'm going to do the RAG. So RAG I was talking about. So for what I have to do, I have to crawl some web page and put that data in vector database, and whenever I will call or make some relevant search, instead of going to LLM, it will ask these tools. With help of these tools, it will respond back. Okay, so I'm going to do RAG. So for that I need a document loader because I have to load from web and all that. And the vector store, there are a lot of vector database. So here you can relate, this is FAS is one of the vector database which stores those content, and embedding, right? then I got those texts from where I have to put into vector database. So what I have to do, I shouldn't say encoding, but it is embedding. So what it does basically, it has to get converted into 0 or 1 numerical format, right? So this is the embedding, OpenAI embedding I'm using. That component will do this. And yeah, this is the text explicator functionality, text related and all that. So I was talking about if I got that corpus of data, I should be doing chunking, right? Instead of giving all the text in one go, I should chunk it, and so that it will get distributed in the vector database, multi-dimensional space in very efficient way. And if I'm doing this chunking, the good part will be kind of things that when I will ask, right? So instead of giving the whole page in a one go, which is not really well, it will give just a few related chunk to me and I will use in my code. So that's where chunking is also important. So this is my web loader. This is my splitter. I am saying that you have to split and all that. Then I am saying that hey fast database, this is your document now, go and store it. So this become my, get into my fast database. How simple it is. In .NET inserting it into database, you guys have to write too many code. Huh? So, and retriever, right? So I have to make it ready that whatever question will come, it has to retrieve. So this is the new terms, you have to understand that. Now, okay, so I have this, right. So I have built that vector database. I have tools. In that tool, I have wiki and FAS toolings, right? But this knowledge, local knowledge also need to be exposed as a tools, so that my LLM will be able to call that. So that's where I'm building this guy as a tool as well. And I'm giving this name. You are language search and search any information about language. So this is the context which will be, and now in the tool I'm adding retriever tool as well. So now in my tool collection I have 3 things, and then I'm going to build a agent now. Okay, so this is chat grok is nothing but so LLM provider also we are having a lot of, right, chat GPTs and Bard and all that. So GPT is kind of somewhat paid, even though I have that API call accounts, I should be able to, but Grok is the another way of hosting, and they are offering some a free way of inferencing. So that's so here to refer that, see how simple it is. I'm saying that okay, chat grok from LangChain grok. So they have already built, I don't need to worry about, wrapper is already ready. So whatever innovation happening, new vector database, new API hoster, LLM hoster coming in the market, this LangChain community is keeping pace with that and building all those frameworks. Just you need to understand how to hook.
One question. So this LLM model is the XCI Grok's that LLM model?
Right.
Okay.
Yeah. So I will call their API as a LLM because my agent will have its own brain, right? So brain is nothing but again LLM. So I have to give that LLM. So for that only I'm calling it. So API key and all that I have loaded here. So here I have built LLM. I am saying, okay, this is your API key, and from that grok, go and take this Llama 3 to 8 billion wala model, right? So I tell that. Then I got a LLM. My LLM is ready for me to consume. Now I'm going to, this is nothing but a prompt template. So I was referring prompt template, right? So for prompt template also you don't need to worry that much. In the market there are a lot of templates. So this is one of OpenAI function agent calling templates. They have already defined. Just you have to refer that. And okay. So now I'm ready with LLM. Now I'm creating agent. So this is the function, right? What I'm doing, nothing but it's all LangChain dot agents, importing that create OpenAI tool agent, and I'm instantiating. I'm giving that agent need LLM, agent need tools, and agent need prompt, right? So I've given all these three, agent is ready, and now agent executors so that it will be ready for execution, and finally I'm telling agent, hey, input, tell me about LangSmith. So I have a RAG LangSmith specific web page. So instead of giving from its own public knowledge, it has to go and call my RAG based tool, right? So what it does, so this is what I was saying, the reasoning capabilities coming up, right? So when I have asked that, so it is saying that LangSmith search. Why? Because in that tool, I have that tool name is LangSmith. Right. So this is the tool name LangSmith search, and I've given this description so that it is able to correlate automatically which agent I have to call, and LangSmith search, and this is the query. It is going and making a call, and all these internal so how it is planning and all those observations, right? It does internally. So nowadays when we are telling in reasoning capabilities, so internally LLM itself, whatever response comes, it thinks evaluate again, is it correct or not? If it is not, then again it will, so internally intelligent is there, it will try to understand. If it is not correct, again it will rethink, and it is required, it will make another tool call. So those capabilities are already there. So so we got this response. So response is, this is our input, and it's able to tell that response. So this response, because here in the trash itself it's saying, right, this is the working, invoking, right? It's saying that now I'm invoking this agent. So my is whatever agent I have built, and I given this tool, 3 tools, it's able to understand that I have to invoke this tool based on my query. Next, when I'm asking something, what is machine learning? So either for machine learning, I have LangSmith specific tool. One is Wikipedia, one is RCA. So it has to go over internet data, right? So internet of data it already has into it. So it has to ask from there, let's see, no, it goes to Wikipedia, sorry about that. So now it is invoking Wikipedia tool, and it's going to search over Wikipedia, and it will get the answer from there. So this is again web search.
How does it know when to invoke Wikipedia or archive?
That's where these LLMs are coming with the reasoning capability. It's able to reason itself based on my input query. So that's where.
Based on trained data, right?
No, that's
So,
what I'm asking.
no. This point is valid. That's where.
Who is deciding what to do?
That's where industry is not trusting fully on this. Sometimes it might be.
I didn't get it. Would you
No.
repeat that?
So how did it got to know? Here it is pretty much straightforward that okay, it seems like what is machine learning? It is able to understand. I am having Wikipedia. Wikipedia has all kind of this basic knowledge, so I should be able to call. The way I am thinking, the LLM is able to think. How it thinks, it's another part of
Depends on how you
understanding.
train the LLM.
So to summarize that, that's where we are calling it out. It has a reasoning capability. The way I am reasoning, LLM is reasoning. It might be that the reasoning will be wrong. 100% it will not be true.
So you pass the LLM object and the tools object to the agent, right?
Right.
But what is the value add of this agent object? I can just pass, I can create a new LLM object and pass the tools to it. What is the additional functionality the agent
fine tune the LangSmith
Right. So,
The additional capability that you want.
additional capability you want to, that's where we are building agent, right? Otherwise, we were happy to directly build a application chatbot and interact
With the
with LLM.
Right.
But here we are thinking of, okay, sometime make a call to my rack-based system, sometime make a call to Wikipedia, and call to another source, right? So that's where this LLM will be having that reasoning capability and able to think of which tool I should be using. And it's not the only this one. People are building step-wise workflow. So that this is a straightforward question. It should not be always like this, right? So when I was telling about this book, The Flight, it's required multi-stage. So that's where that workflow system we have to build, multi-stage. Or this reasoning agents, the way we are building, similar way, we have to give a right prompt and test it out so that it should be able to perform that task.
So LLMs don't have any state in themselves. They are completely stateless. So agents are adding memory and like they're storing the state, so to speak, between different steps in the work.
Right. So memory part, I haven't added here anything.
So to add to that,
Before this one, we asked one question regarding, tell me about Langsmith. It was not going to Wikipedia because you have provided Langsmith is a RAG.
Right.
That's why it was not going to Wikipedia.
Correct.
Now because we are asking machine learning,
Yes.
there's no context, that's why it's going to Wikipedia.
Correct. So that's where when you are building agent, right, you have to keep in mind, here I have given just one description. Okay. So when I build that agent, here, just I given the name and mentioned that search any information about Langsmith. So that it's understand that okay, for Langsmith I have to call this name. But if you are building some system, it should not be saying like this. You should be explaining whole thing. For this task, this particular tool is responsible for this activity, this activity. More detail it will provide. It will able to build that condition and able to direct to this particular tool. So those are things, real development activities. Testing it out and all that. Okay, so now here I am telling that what is this paper, this number. So from RCU, So for RC, this is the transformer attention is all you need. This is the paper, okay. And in RC, we are having all those research papers, individual numbers. So when I ask this, what is this paper? So because I given RC as a tool, it able to understand the way I know what is the RC, because it has all internet data and it's know what is this RC all about. So now instead of going to other, it will invoking RC tool. Okay, and it's querying this is the ID, it goes, and now it's saying that okay, so it's got that this is the attention is all you need. This is the authors and see what is doing. Again, for more detail, it's making a call to Wikipedia also, and it's getting page attention you all need, and this is the summary from that side. Okay, so this is the response, input and output we are getting. So with this example, hopefully I am able to onboard you guys. Not a concrete things, but at least you are able to think of, right?
Yes. Yes.
That was my overall goal.
Yeah, right.
Thank you.
One question, will you be able to put this in a GitHub so that we can go through the code?
Correct. Oh, okay. Sorry about that. Hold a minute. Hold a minute, guys. I have to do some my publicity also, no? Okay, thank you very much. And these are my channels. You connect, and any information required, I think hopefully you can take me. I should be able to provide. Okay, thank you.
Very well, thank you.
So one thing I'm mostly, listener. Actually, I usually come and sit and I ask questions. I'm not sure. And I wake up whenever new technology or trends comes in the market. So once it will get embraced and I will get a very reasonable work, probably I will be again listening. So I will encourage you guys come up and share your thoughts because this is the platform at least we are able to share something. Yeah, thank you.
Thank you.